So, as our lovely host introduced me, my name is Kevin Crawley, and today we're going to talk a little bit about how we can do more with less integration and unit testing. And the whole premise behind this talk was that I've been a software developer for almost 20 years now. I've gone through a period where I was gung-ho about testing, and I thought it was the best thing to ever come to software development. And to be honest with you, I learned quite a bit from it. I learned how to become a better developer, how to decouple systems better, how to be more thoughtful when I design the system. But along the way, there were some trade-offs that came about, and I think some of those trade-offs are often overlooked. And I want to talk a little bit more about those and how we can build systems in a manner in which can be tested essentially in production. So again, just a little bit about myself. I work for a company called Instana. We are a application performance management company. We just do really fancy monitoring. My role there is developer relations. What that means is I do blog posts, I talk at conferences, webinars, and I also have a product focus on SRE topics. So I work with our product managers and our developers to help build tools in that particular arena. I'm also the principal SRE at a startup out of Nashville, Tennessee, and I'm going to talk a little bit about how we leverage advanced monitoring, distributed tracing at Single Music to help us deliver our software to our customers. Notably also, I'm the principal SRE because I'm the only one there. So with that, let's get started. So some of the things we're going to talk about is initially the culture of testing. Like, how did it come about, this idea that we had to unit test everything? We had to have all these integration tests stood up to be able to ship code to production. And we're going to talk a little bit about why you might not want to do that, depending on your business and the context of the problems you're solving. We're going to talk about what is advanced monitoring, like how can we replace testing with monitoring tools, and what do we need to be able to do that? And then we're going to take a look at Single Music and how we use observability tooling, advanced monitoring, to essentially displace unit and integration testing. So how many would say that testing is something that is part of the Agile framework? Like, it's actually in there, right? If we go through the Agile framework, there's nothing in there about testing. Its primary edict is just to ship quality production software. And I would argue that the way that we could do this is by making sure that we're building good software and that we can observe it while in production in order to be able to fix problems before our customers really notice it. And we have the tools today to do this through things like canary testing, A/B testing, blue-green deployments. These are things that we can actually do. And this is like an example of some things that I don't necessarily agree with. I believe that testing at the end is actually a good idea. And the reason is because our systems are moving so fast today that we're building software so rapidly that by the time we define the test, usually the actual scope is probably changed. So we just end up having to refactor it anyways. Again, I'm not going to go through every single one of these because this is only a 20-minute talk. But again, this is just sort of the culture that has grown up around testing, and I just simply don't agree with it. And this is why. They did a study, some academics did a study around the effects of test-driven development, and you can read more about these studies. I'll publish these on my Twitter, the slides. You're welcome to go check them out afterwards. But what this essentially tells us is that, sure, we reduce defects when we do testing, but we trade that off with the effort and the coupling and the productivity of our software. So if we're going to do a lot of testing up front, we are going to slow down. And that's not necessarily what we want in today's business environment, unless, of course, you're a bank or you're working with nuclear reactors or something mission critical or life critical. The idea here is if somebody can die as a result of your software, you probably want to write tests. right? So I would make the argument that unit testing is kind of like putting your code in a tar pit. We have more abstraction, we have more logic, we have more code, we slow down our velocity, and we reduce our productivity. And the reason we're seeing this is because as our environmental complexity ramps up, as we introduce more services, more endpoints, more systems, the benefits of early testing tend to go down. And what's the answer to this? More integration testing. Now, just a show of hands, when your production is broken, like literally your world's on fire, how many of you wait for integration tests to pass? Yeah, very, very few. Like the whole idea is we need to get this fixed out right now, right? So I like this quote. I found it on Twitter. I don't know who said it, but everybody has a testing environment. Some people are lucky enough to have a totally separate environment to run production. The idea here is that we're already testing in production. Embrace it. Let's learn to love it. So again, I said at the beginning, I don't necessarily think we should just throw testing out of our lives. We still need to test, and some of the things we may want to test, up here, obviously, nuclear reactor control systems, aircraft, software. Open source libraries is a big one because, a lot of times, mission critical software will run on open source, so you want to make sure that you're shipping good software. And then, honestly, regressions. If you are consistently having a problem in your software that keeps coming up, and you've identified the code path, put a test around it, and that way you're not interrupting your users unnecessarily. What are things that we shouldn't test? Non-critical user actions, things that can be monitored, like the ability to like somebody's avocado toast, fence post errors, CRUD, edge concerns, minor details. So I want to talk a little bit about distributed tracing and how we can leverage that in conjunction with our monitoring systems to displace this testing idea. Distributed tracing came about in 2010 from Google, and what they had discovered in their very, very large organization is they had hundreds of teams, thousands of services, dozens of programming languages, and they had no common way to monitor the transactions that were occurring between each one. So they created something called Dapper. And how Dapper works is that essentially every single request that is generated in between a service or to a database or to a message queue has a header attached to it. And that header helps the agent or the monitoring system correlate the actions between the two. So you can track things like how long did one request take to another. Now, this becomes somewhat laborious to implement because you're essentially having to add on functionality to every single method that makes a transaction or handles a transaction, whether it be a message queue system or a database transaction system like JDBC. Fortunately, there's libraries out there that will do a lot of the work for you. Instana will do all of the work for you. I don't have time to unpack that, but if you want to learn more about it, come see me at my booth and I'll talk to you about it. So what do we get from this information? Well, we get a lot of data that's perfect for aggregation, machine learning, performance analysis, along with testing and debugging. Or rather, we get a huge data lake that we're going to drown in if we don't do anything with it. And so what do we do with it? Well, we bring it all together. We contextualize it. We do something what is called request-scoped aggregated events. And if we bring together all of these different data points in our monitoring systems, then all of a sudden we are empowered to understand exactly what happened, where, and when our systems decide to break. And so what does aggregated request scoped events actually mean? It means that we're creating individual buckets of data that are grouped by services, applications, and endpoints. We roll up what is called the golden metrics, throughput, latency, error rate, and saturation, for all of those buckets, and we retain the context of those metrics and those traces so that when a particular trace or a span fails, we can tie it back to the infrastructure. We can tie it back to the container, to the Kubernetes pod, to the host, to the cloud provider, to the zone. We have all of these things connected, and it makes it very easy to figure out where the problem existed. So a case study about Single Music. This is literally a company I started in my garage. We ran on a Dell R815 for about 6 months, and we launched with Docker Swarm as our orchestrator. It was all container-based microservices. At some point, I was overseas. I was speaking at a conference somewhere, and my power went out. And so it's 2 o'clock at 2 o'clock in the morning. My CTO is on the phone with me saying, "Kevin, fix it." And I'm like, "Dude, I'm across the ocean. How am I going to fix that?" And he's like, "I don't know. Call your spouse. Have her turn on your server." And I'm like, literally on the phone with my wife at 2 o'clock in the morning, trying to walk her through powering up a server in my garage. And she was like, "I'm never doing that again." So that's the story of why we moved to AWS. So this system processes around 300,000 transactions an hour. That's internally, 20,000 from the outside. We have over 20 integrations with SoundCloud, Shopify, Apple Music, all kinds of stuff. We are over 150,000 lines of code, and we literally have less than 15% test coverage. Normally, nobody would brag about that, right? Like 15%, that's terrible. But it's actually really, really been advantageous to us because we don't have to worry about spending our time writing tests because we have the tools to tell us when something breaks. And we have you may have noticed some of the bands here. We're in over 1,500 stores now. And again, we have a system in which people rely upon. So we have to make sure it works correctly. So what do? We do digital music reporting, fulfillment, distribution, analytics, sales tracking, landing pages, and a whole bunch of stuff. We built quite a few services over the past couple years. And how do we manage this? Well, we have Instana to help us visualize our production system so we can easily visualize our host and the containers that are running within it. Within each one of those systems is an application and a container, and we can quickly jump into those services to understand what their performance is. As you can see here, I just quickly jumped into a dashboard, and I can see the details around the JVM, around the container metrics, as well as the host metrics. Now, what you're seeing here is a distributed transaction map that is actually built from all of those individual calls or spans that are being collected every time one service talks to another service. That generates some telemetry. It says, well, this service talked to that service, this is how long it took, maybe there was an error, maybe there wasn't. But again, we get a detailed map and understanding of all of our systems and the behavior between them. We also get interactive dashboards so that we can easily understand the health and quality of our applications and services. Now, if you're going to go about the route of not doing as much testing and leveraging observability tools to replace it, then what you need is the ability to easily identify where issues may be occurring. And that's where aggregated dashboards help out. And it also helps if they're interactive. So let me kind of unpack what we're looking at here. This is a production dashboard of all of the services in Single Music. This is how many incoming calls have happened over the last 12 hours. This is my average error rate over the 12 hours. And this is my latency and processing times. We have what is called a P50, P90, P95, and P99. And these percentiles are important because with P99 percentiles, what that's essentially saying is that less than 1% of my transactions may be experiencing additional latency over my mean. And that's important because that helps you identify outliers and issues that may be impacting your system. We also get an interactive list of the endpoints and the services which may be causing problems in our system. And we can click on those and easily dive into another dashboard that gives us these statistics. Some of the problems that we've been able to solve with this is that, as we can see here, we have a endpoint being called. This endpoint is essentially creating a product in the Shopify catalog. We can see how many interactions with other systems this particular endpoint requested, and we can see how many errors there were, how many warnings there were, and how long the request took. We can also see that there was an error at some point in this transaction, and if we click on that, we get the details around that error and the context of where that error occurred, what service was being called, and what message queue was being invoked, and then what the error ultimately was, and it was a database transaction failing, and there was a constraint violation. And so this easily allows us to understand where an issue occurs and where in the code we need to fix it, because you can see there we also have a stack trace. We can also visualize patterns. We can understand scope and algorithms. So here, this is an asynchronous transaction. We have one batch of queries in which ends, messages dropped on a queue, and then you can see below additional activity occurs. Typically in distributed systems and message queue systems, if you want to correlate work from one from the entry point all the way to the endpoint, you're usually grepping and tailing through logs for hours trying to figure this stuff out. But here, it literally puts it in one place for you. It also lets us visualize patterns in our programming. So you can see here we have an exponential backoff actually occurring against one of our databases. And again, this just helps us confirm behaviors in our software. And we can also solve problems with it. In this case, we can see here on the right-hand side that there's a rise in latency. And what we discovered after being able to find this in our dashboard is that we had a Hibernate query causing an on log n rise in latency. And this was because we had created a transaction entry system in which anytime a transaction was added, it loaded all the other transactions beforehand. What that resulted in is this terrible rise in latency as key slope. And the point here being is once we fixed it, we could see where the fix was applied, and we can move on with our lives. The other thing that we've done with it is we can identify areas where systems are blocking transactions. So here we can see that these particular transactions are blocking, they're preventing other work from occurring. And so we added caching, we added Redis to those calls, and this was an authentication call, and we didn't account for token policies changing, and they suddenly began to expire after about 30 seconds. And the alerting around this endpoint raised our awareness around it. Now, in this case, we maybe could have wrote a test for this, but it would have been very edge case, and we would have had to been able to predict the future to write a test for that. Here we can see where the error is occurring around 30 seconds, and we can see the parameters in the output of our error log. Once we've been able to fix it, though, we can see that our request moves on from 30 to 60 seconds, and the request finishes. So just to summarize, microservices allowed single music for us to scale and meet the needs of some of the world's largest bands. The observability tooling has helped us become more effective at deploying and managing these systems, and it has effectively allowed us to step away from having to write all these tests, because whenever there is an issue in production, we know where it is, and we know exactly when it happened, and typically we know how to fix it. So the idea of having to stand up and scaffold a ton of tests to prove some magical or some mysterious thing that might happen in the future just doesn't apply to us. And we rely on Instana because we want to focus on delivering value to our customers, not managing third-party or all kinds of crazy monitoring tools ourselves. So Ed Keys, a site reliable engineer at Google, said that sufficiently advanced monitoring is indistinguishable from testing. Now, how many here do you think that your organization could use more observability? Yeah, quite a few hands. That's cool, because we have free trials. Go to instana.com and you can sign up. And you can also stop by our booth at 511 or schedule some time to meet with us. I'll also be off here to the side if you want to ask me some questions for a few minutes. I have another session here in about an hour. Thank you again. Be sure to complete the session, and you'll have a great rest of the show.